Most of us are familiar with street maps and political maps, but geospatial data can be harnessed to tell stories about data in unique ways. A great example of this is Charles Minard's 1869 map that tells the story of Napoleon's attempt to invade Moscow. The original map is in French, so let's look at a modern reproduction of the map in English. Take a moment to study the map. This map may not look like a traditional map, but it communicates information about places very effectively. Starting from the far left of the map, the wide, light gray line represents the size of Napoleon's army as it started out from Kovno in present-day Lithuania with 422,000 men. As the light gray line extends to the right, notice that it shrinks, meaning that the army slowly dwindles in size on the march to Moscow. By the time Moscow is reached, the size of the army is only 100,000, at which point Napoleon turned the army around. The army's return is represented by the dark gray line, which can then be read from right to left. The dark gray line continues to get slimmer as the army makes its way back to Kovno. By the time the army makes its way back to Kovno, it is down to 10,000 men, about 2% of its original size. Notice the temperature readings over time underneath the map, which show that significant drops in temperature often correspond to a significant reduction in the size of the army that is left. Notice also the representation of rivers in the map. River crossings also seem to contribute to notable declines in troop numbers. Why is Charles Minard's map of Napoleon's march to Moscow so effective? In his map, Minard uses both traditional cartographic principles of mapmaking, such as landmarks and scale, along with other principles of data visualization to help viewers understand the story of the data, the ultimately disastrous attempt by Napoleon to invade Moscow. Despite the fact that this map, created in 1869, was created long before digital geospatial visualization tools were available, Minard creates a compelling story that combines several different types of data in an easy-to-understand visual. The data has a headline and tells a story. The viewer can follow the marching army across the map and watch the representation of the army size dwindle over time. The visualization allows the viewer to explore the data from multiple angles, geographic, over time, using temperature, which makes the visualization interesting to the viewer. This map was meant to be viewed statically, in print. Despite not being interactive, Minard's visualization nonetheless allows the viewer to explore the data. Key features of the map include landmarks, scale, and legend. Landmarks. Minard incorporates a few geographic points of reference, the names of cities from Kovno to Moscow, to help the viewer orient themselves to the map's geography. However, all extraneous data is removed to help the user focus on the key information presented in the map. Because the data being presented is complex, incorporating time, temperature, and geographic information, Minard provides just enough detail for the viewer to understand what they need to know to read the map, without overwhelming the viewer with extraneous data. Scale. Scale is the amount that an area or distance has been reduced in order to be included in the map. In maps, scale is expressed as a ratio of distance shown on the map to actual distance on the ground. While Minard expresses his scale in the unit of distance used at the time, common leagues of France, most modern maps will use ratios of inches or centimeters to miles or kilometers. For example, a scale of 1 to 63,360 means that 1 inch on the map is equal to 63,360 inches on the ground, or approximately 1 mile. Legend. Geospatial visualizations often use symbols or colors to express meaning, and legends provide a kind of index to help the viewer understand the meaning of those symbols. For example, the colors used in this choropleth map are defined with this legend on the left, and differently colored icons are explained with the legend on the right.